Hello dear students, welcome back to the rapid revision video of environment. So in this we're going to look at everything water, air, sewage, refuse, waste disposal, overcrowding, everything, okay, in gist. All right, so let's start with the first part, which is water. Just a few questions. Basic physiological requirement of drinking water was estimated, we all know, at 2 liters per head per day. Now the next one, so this is just like a height point, okay. A daily supply of per capita is adequate to meet the needs for all urban domestic purposes. So how much daily supply per capita? So please remember, it is 150 to 200 liters per capita per day. Okay, so that is sufficient to meet the needs for all urban domestic purposes. This is a PYQ also. Similarly, for rural domestic purposes, what is the daily supply of how much water per capita per day is adequate to meet the demands for all rural domestic purposes? So that is 40 to 60 liters per capita per day. Okay. All right. Next, this is again a PYQ. Okay, so first few lines are just highlight points. What is the criteria for identifying a problem habitation? Okay, so drinking water source point is not within 1.6 kilometers in plain areas or 100-meter elevation in hilly area. So wherever there is no drinking water point source within 1.6 kilometers in plain areas or 100-meter elevation in hilly areas, it is a problem habitation. Water, or if you start digging the ground, water is not available till a depth of 15 meters. Like if to go on digging, you will see water only after 15 meters. So that is problem habitation. Okay, so there's one more term I wanted to discuss with you, which is safe yield of a source. Okay, safe yield of a source. Now, in the main lectures, you have learned there are different sources of water: rainwater, groundwater, surface water. Okay, so what is safe yield of a source? So safe yield of a source is the yield which is adequate for 95% of year. Okay, it could be anything: rainwater ka yield, or tube wells, that is surface water, groundwater, whatever. Okay, which was the purest form of water? Rainwater is the purest form of water. So again, these are some high points that have come before us, PYQs. All right. Public health classification of water and diseases. So you all know water wash disease ka example, scabies, trachoma, shigella. This is very important. Inadequate use of water. Water washed means inadequate use of water for proper hygiene. Inadequate use of water to maintain proper hygiene. Okay, to maintain proper hygiene. So we are not using, you're not taking your wash daily or something like that. Okay, water is not used adequately to maintain hygiene. What is water-based disease, guys? Example was schistosomiasis and dracunculiasis. Now, you remember dracunculiasis, what is the host over here? It was the cyclops, guinea worm infection, cyclops, okay? So, in water-based disease, it depends on an aquatic host for transmission. Okay, aquatic host is required for transmission. Aquatic host for transmission. Like in dracunculiasis, it is cyclops. Okay, guinea worm infection, it was cyclops. Schistosomiasis, it was snails. Okay, waterborne diseases, like just like we eat contaminated food and have foodborne diseases. Similarly, if we drink contaminated water, okay, contaminated water, it can lead to waterborne diseases. GI is gastrointestinal. Water related are mosquito-borne infections where the vectors require water for breeding. Just for your revision, okay, you all remember Anopheles breathes in clean stagnant water, right? Anopheles requires clean stagnant water for breeding. Okay, Culex, it's a nuisance mosquito, requires dirty water for breeding. Okay, the larva, okay, we are basically concerned about the larva. And of course, we have Aedes. So Aedes is breeding where? Artificial collection of water. Okay, so again, this is a very, very important slide which has come as a PYQ. Okay, so we have revised that as well. Next, let us talk about some acceptability aspects for water. So when there is surveillance of drinking water quality, okay, so what are the things that are desired in drinking water? So drinking water quality. Now, if you look at water, you see that it is colorless, it is tasteless. Okay, so it is turbid, like it is not dirty, it appears transparent. Okay, so turbidity is something something which is like a physical criteria. Okay, so these are all what? Physical criteria. Like when I talk about turbidity, okay, turbidity up to 5 NTU is permitted. Nephrometric turbid unit. Okay, this is what? Nephrometric turbid unit. So water turbidity allowed is up to 5 NTU. Color, we all know it should be colorless, okay, but color is measured in a unit which could be up to 15 TCU. TCU means true color units, and now we also use another unit for that, which is 5 Hazen unit. Okay, 5 Hazen unit. Taste and odorless. Odor, of course, there should be no taste, tasteless. Okay, and of course it should be odorless. Then they ask you, what about chlorides? So the standards prescribed for chloride is 200 milligram per liter, but the maximum permissible level that can go is 600. So if the question says standard prescribed for chloride in water, 200, but the maximum permissible level that it can go up to 600. Okay, hardness, we all know 100 to 300 milligram per liter. You could also say it as 100 to 300 ppm per liter. Okay, but parts per million. Softening of water is recommended at, this is a PYQ, 150 to 300 milligram per liter. What about the pH? Acceptable is 6.5 to 8.5. But please remember, chlorine, which is one of the good disinfecting agents, it acts best at pH of 7. Hydrogen sulfide taste and odor threshold is so much, 0.05 to 1 milligram. Iron is also up to this thing, but more important is total dissolved solids. Like chloride, 200 prescribed, okay, but maximum permissible level is 600. Similarly, for total dissolved solid, how much it is? Less than 600 milligram per liter. Prescribed TDS level, okay, prescribed permissible, like standard prescribed 600, but what is the permissible level? It is up to 1000. Okay, so this is surveillance of drinking water quality. Now another question which is very important is biological indicator of water. Okay, now ideally water should not have bacteria, virus, protozoa, nothing. Okay, so for bacteriological surveillance of drinking water, what do we select? Okay, so please remember, most reliable evidence of fecal contamination of water, we all know, is coliform bacteria. Okay, so basically here we are going to talk about bacteriological surveillance of drinking water. Okay, bacteriological surveillance. So this is again a PYQ, bacteriological surveillance of drinking water. So in this, please remember, the most reliable evidence of fecal contamination, most reliable evidence, okay, most reliable evidence of fecal contamination of drinking water is provided by fecal contamination of drinking water is provided by E. coli, or E. coli is the most commonly used indicator also for evidence of fecal contamination of drinking water. Okay, then presence of which organism provides recent contamination of drinking water? So evidence of recent contamination of drinking water, everybody, evidence of recent contamination of drinking water is provided by fecal streptococci. Okay, fecal streptococci, that is evidence of recent contamination. And third one, evidence of remote contamination of drinking water. Remote contamination means long standing. So evidence of remote contamination of drinking water is provided by what? Clostridium perfringens. Okay, Clostridium perfringens, or Welchi, you can say. Okay, so this is bacteriological surveillance. Now, is there any screening test available for that? Yes. So I'll just put it here. What is the screening test? Okay, for presence of E. coli. So remember, the name of the test was PSP. Okay, presumptive coliform test. Okay, so it is presumptive coliform test. Okay, presumptive coliform test, or you could also call it as multiple tube method. Okay, multiple tube method. Okay, so this is it. And what about the confirmatory test for E. coli? Okay, that yes, it is there. So confirmatory test for the presence of E. coli in water, what was the mnemonic? EIC. Okay, Eichmann test. Okay, with the name is Eichmann test, or indole test, okay, and what is the last one? Citrate utilization, okay, citrate utilization. But what is the most reliable evidence? That is provided by coliform. Coliform, even if we see coliform in drinking water, it means it has been contaminated, okay. Next, if you want to see the detail, you can refer to the lecture on water, which has been discussed in the main series, okay. Now let's talk about purification of water on small scale. How do you advise to purify water on small scale? Of course, boiling, this is the best method, okay. But is it preferred? Can you advise boiling to people residing in a slum? No. Why? Because number one, it is expensive. Okay. Number two, it has no residual property. Okay. No residual property. What does that mean? That once you've boiled water, you have to reboil it again within 4 to 6 hours. So imagine the amount of gas that it's going to take. And if you go and prescribe it to people residing in urban slum, they will get very angry. Okay. But it is best. Why? Because as discussed in the previous lectures also, it kills everything. Okay. Yeah, it kills everything. All right. That is why it kills all cysts, all ovas, all spores, everything. Okay. So obviously we have to know then what do we use other than boiling. So please remember chlorination. Chlorination is the second best method. Okay. Now you can see it is second also and best also. Why second? It is second because it does not kill everything. Okay. Cannot kill. Just remember, cannot kill all cysts, all ova spores. Okay, all cysts, all ova spores. Plus, when we have to kill, suppose I need to kill poliovirus. Okay, we have to kill poliovirus or we need to kill cyclops. Okay, then what has to be done? The amount of chlorine has to be increased. Okay, so the dose of chlorine increase. So when dose of chlorine will increase, we'll have to add more. It will alter the taste and smell. Okay, alter taste and smell. So that is one of the reason. Like to kill poliovirus or cyclops, we need to have a residual level of chlorine up to 2 or more than that. Okay, so it alters taste and smell. But why is it best? Now remember, chlorine is best because it has what is known as residual action. Residual action. What is the meaning of this residual action? That once you've added chlorine to water, it remains disinfected. You do not need to treat again and again. Okay, so we do not need to treat water. We do not need to treat water again and again. Remains disinfected. Okay, that is what is the meaning of residual property. It remains disinfected. Got it? Now next line, chlorine acts best at pH of 7 and the main disinfecting property of chlorine is due to hypochlorous acid, as it causes 90% disinfection and the rest 10 is by hypochlorite ion. These are some golden points. 33% of chlorine is available in bleaching powder. So bleaching powder is the most commonly used form of chlorine. Okay, most commonly used form of chlorine is which one? It is in which form is chlorine most commonly used? Bleaching powder. 100 grams of bleaching powder is going to release 33 grams of chlorine. And remember, this was present as one of the options. 2.5 grams bleaching powder is required for 1000 liters of water. Now, just for your quick revision, I'll just quickly tell you, when you add chlorine to water, it forms HOCl plus HCl. This is hydrochloric acid, which is neutralized by the alkalinity of water. But HOCl, okay, what happens? This is what? Hypochlorous acid. Okay, this is what? Hypochlorous acid. And this hypochlorous acid is responsible for 90% of disinfect property of chlorine. Okay, now what happens? If the pH is slightly more than 7, this HOCl can further dissociate into H plus plus OCl minus. This OCl minus is hypochlorite ion. Okay, and 10% of disinfecting property is because of this hypochlorite. So if anybody asks you, disinfecting property of chlorine is due to, it is hypochlorite, like it is due to both hypochlorous and hypochlorite. But major disinfecting property is hypochlorous. And this where chlorine is combining with water. Okay, this entire thing is combined chlorine. Okay, this entire thing is combined chlorine. Now after this combined chlorine has been achieved, so how much of chlorine is added to water to disinfect it? What is it known? If somebody asks you how much chlorine is added to water, water to disinfect it. Okay, this is actually nothing but a term known as chlorine demand. Okay, what is it? Chlorine demand means how much of chlorine is being demanded by water to disinfect it. So first thing, we have to add some chlorine to a particular amount of water to disinfect it. That is what is chlorine demand. And how do we estimate the chlorine demand of water? By an instrument known as Horrocks apparatus. Okay, so Horrocks apparatus is something which is used to estimate the chlorine demand of water. Other than that, chlorine also oxidizes just a golden point. Iron, manganese, hydrogen sulfide, controls algae, slime organisms, aids coagulation, which is not being done by any other method of disinfection. Okay, so chlorine demand of water is the amount of chlorine which is needed to destroy bacteria and to oxidize all organic matter and ammonia cal substances present in water, meaning to purify water. And how much of that chlorine is needed to purify water? That is estimated by what is known as Horrocks apparatus. Okay, so this estimates the chlorine demand of water, which is the amount of bleaching powder required for disinfection. Look at this. This is an instrument of Horrocks apparatus. Now, just for your revision, it consists of one black cup, okay, and it consists of 6 white cups, okay. Now, in the black cup, what do? I don't have a black, I can't choose over here. So, suppose this is the black cup, okay. So, in the black cup, whichever water has to be disinfected, okay, that is put, all right. And in this, we add the indicator. So, what is the indicator? That is an MCQ in Horrocks apparatus, starch iodide, okay. So, in the black cup, what do? We prepare the solution, and then you have 6 white cups, okay. So, this is black cup, all right. We have 6 white cups. Let me put a different color for this, okay, might get confusing for you. Okay, then we have 1, 2, 3, 4, 5 and 6 white cups. In these 6 white cups, please remember water is filled at increasing level. Okay, there is marks like this. Water is filled at increasing level, and then we are going to add 2 drops of solution to each of these white cups. You will notice that there is one cup which is going to change its color. So the question comes, what is the change in color that we notice? The change in color is to blue. So there is one cup which is going to change in color. It could be the first, second, third, fourth, fifth, or the 6th white cup, whichever. Now, suppose the second cup changes color, automatically third, fourth, fifth, and 6th will change color. So, what you need to remember over here is that N into 2 grams of bleaching powder, okay, N into 2 grams of bleaching powder will disinfect how much? Will disinfect 455 liters of water, okay. This is going to remain constant, okay. N into 2 grams of bleaching powder will disinfect 455 liters of water. And what is N, guys? N is the first cup, everybody, which shows color change, okay, which shows color change. Now, suppose it is the second cup which shows color change. So, N would become 2, and automatically rest of the cups will show color change. So, for your rapid revision, you need to know this formula. N into 2 grams of bleaching powder will disinfect 455 liters of water. And what is N? N is the first cup which is going to show color change. Got it? So, Horrocks apparatus is used to calculate chlorine demand. Indicator is starch iodide, color change is happening is blue, and the formula you must know. Now, after chlorine demand is estimated, that how much amount of chlorine is required to disinfect a particular amount of water, we are going to add some extra amount of chlorine to water. That is what is known as residual or free chlorine. So, remember, after chlorine demand is estimated, okay, after chlorine demand is estimated, all right, extra amount of chlorine is added. Extra amount of chlorine added to water. Why? To keep it disinfected, okay, to keep it disinfected. This extra amount of chlorine which is added to water to keep it disinfected is known as free or residual chlorine, and you estimate this by instruments which is known as chloroscope. This is the image of a chloroscope. Plus, this free or residual chlorine can also be estimated by 2 tests which we have studied, orthotoluidine test and OTA test, orthotoluidine arsenate test, okay. That's how you estimate the free or residual chlorine. So what is the level of free or residual chlorine that should be present in water? See, in drinking water, it should be more than equal to 0.5 milligram per liter or ppm with a contact period of 1 hour. To kill cyclops in drinking water, more than 2 milligram per liter or ppm. Also to kill poliovirus, okay, also to kill poliovirus, the level of free or residual chlorine should be more than equal to 2 milligram per liter or ppm. Everywhere, guys, contact period is of 1 hour. ठीक है, contact period of 1 hour. This is a favorite PYQ. And if you have to clean swimming pools, the level of free or residual chlorine is 1 or more than 1. Okay, but remember, contact period is not half an hour, it is 1 hour. Okay, like I said, test for chlorination, or when you have to also estimate free or residual chlorine, we can use which other test? Orthotoluidine test or OTA. A over here is arsenic. Okay, now which is better, OT test or OTA test? Now see what happens. Yeah, what happens over here that, okay, so you have to address the question which is better, OT test or OTA test to estimate chlorine demand. Now remember, first in chlorine we added water, in water we added chlorine to disinfect it. So that was what was known as combined chlorine, right? Combined chlorine. Then after combined chlorine has been estimated, which is estimated using a Horrocks apparatus, what are we doing? We are adding some extra amount of chlorine, which is known as what? Free/residual chlorine, right? So this is equal to what? The total amount of chlorine added to water. Total amount of chlorine added to water. Okay, now if you take OTA test, okay, it can estimate, all right, it can estimate both free and combined chlorine separately. This is what is a PYQ, okay? And if you take OT test, okay, it can estimate free chlorine separately but not combined chlorine. How will it estimate combined chlorine? It will estimate combined chlorine by total minus free chlorine. Okay, total minus B. So which is better? OTA test is better because it can estimate both free and combined chlorine separately. And how do you know that it is free chlorine, guys? So see, which is better, OTA test or OT test? OTA test is better because it detects both free and combined chlorine separately, and it is also not affected by interfering substances. Plus remember, there is a color change which is yellow color change. Okay, if you see this within 15 seconds, there's a color change which is produced within 10 to 15 seconds. So the yellow color change which occurs within 10 to 15 seconds is due to the presence of free chlorine, guys. Okay, never say combined. After that, whatever color you see yellow, it's due to the effect of both. But within 10 to 15 seconds, the yellow color that you see is because of free chlorine. Okay? So just to sum up, disinfecting action of chlorine is mainly due to hypochlorous acid, 90%. But if somebody asks you disinfecting properties due to both HOCl and OCl minus, hypochlorous and hypochlorite ion. Minimum recommended concentration of free chlorine, okay? So minimum recommended concentration of free chlorine has to be how much? Free or residual chlorine, 0.5 milligram per liter for a contact period of 1 hour, okay? Total dose of chlorine already done, chlorine demand plus free residual chlorine. Breakpoint chlorination, yes, point at which chlorine demand has been met, okay, point at which chlorine demand of water met. Okay, where we have estimated how much chlorine is required to disinfect it. Most commonly used form of chlorine we already know is bleaching powder. Okay, there's something known as stabilized bleach, bleaching powder mixed with excess of lime which retains its strength. Okay, This was on small scale. If somebody asks you just to revise, how do you purify water on large scale? So you know rapid and slow sand filters. Rapid is preferred. Okay, rapid is preferred. Why? Because it is fast and it occupies less space. Okay. Plus, remember, no prior storage is needed. Okay, no prior storage is also required. No prior storage in rapid sand filter is required, and filtration is happening through a sand bed. So this is mechanical filters. Okay, there on top of the sand bed there is no biological layer. But slow sand filter, what is the mode of action? There is a Schmutzdeck layer or a biological layer, or we call it as a vital layer, or we call it as a Zuglier layer, which is present on top of the sand bed, which is the main thing which is achieving filtration of water. Okay, so it occupies more space. Rate of filtration is also slow, plus it requires prior storage is also needed. Okay, so that is important. But it can filter sand size up to 0.2 to 0.3 mm. That was asked in your exams. Rapid sand filter 0.4 to 0.7. So which is preferred? Rapid sand filter for large purification. How do you identify it? On top of sand bed there is no vital or biological or Zuglier layer. Okay. Now, hardness of water is a PYQ. So we'll do that. Two types of hardness, temporary or permanent. Temporary hardness is due to bicarbonates of, bicarbonates of calcium and magnesium. Calcium and magnesium bicarbonates. But permanent hardness is due to chlorides, sulfates and nitrates of calcium and magnesium. Okay? So you have to remember this mnemonic. CNS, chlorides, nitrates and sulfates. Okay, so they ask you this. What was the question that actually came? Hardness of water, is it protecting from some disease? Yes, it is protects from what? Cardiovascular diseases, CVS diseases, in case it comes. Okay, so bicarbonates also of calcium and magnesium bicarbonates, temporary hardness, calcium and magnesium chloride, nitrate, sulfates, permanent hardness. So level of hardness you can remember, soft water is 50 milligram. Okay, what is it? Less than 50 milligram per liter. This is also expressed as 50 ppm. But this one is what? Milli equivalent. Okay, 1 milli equivalent liter of hardness is 50 milligram CaCO3 or 50 ppm. Moderately hard is 1 to 2. Hard water is 3 to 6. Very hard water is more than 6. So when do you recommend softening? Okay, softening of water is recommended at, that is very important, 150 to 300 milligram per liter. Okay, so that is an important question. Or when the water is 3 to 6 milli equivalent per liter. Okay? That was about water. Let's start our rapid revision with air. So let us start with some rapid revision points for air pollution. These are all PYQ, guys. Primary pollutants, name them. Sulfur dioxide, nitrogen dioxide, carbon monoxide, hydrocarbons, chlorofluorocarbons, ammonia, metals like lead, cadmium, copper, nickel, particulate matter. What are secondary air pollutants? They are formed by combination of primary pollutants. Okay, they are formed by combination of primary pollutants. So what is the PYQ? This ground level ozone. Okay, because remember there's an ozone layer in stratosphere also, which is actually good because it's cutting out the harmful ionizing radiations from the sun. But there is something which is leading to the depletion of that ozone layer, which is chlorofluorocarbons. Okay, because of which global warming is happening. So you have to know the name. But if the question comes ground level ozone, it is secondary air pollutants. So name of primary and secondary air pollutants. Then of course they are asking you what are the indicators of air pollution. So sulfur dioxide is the best indicator for air pollution. Other indicators for air pollution, what do we call them? Smoke or soiling index. Soiling index is a measure of smoke. Just remember that. Don't say soiling index is an indicator of something to do with the soil. No. Soiling index is an indicator of air pollution. It measures smoke. Then another indicator is we can measure the grit and dust in the atmosphere. So grit and dust measurement. How much is the haze, coefficient of haze? And of course something known as air pollution index. API came last time in the exams. This is also given by, API has been given by Central Pollution Control Board. Okay, so some golden points. See, best indicator of air pollution is sulfur dioxide. So recommended level of sulfur dioxide in 24-hour exposure is less than 20 mcg per cubic meters. Now remember, this can come as an expected MCQ. But if they ask you which is the most common and widely distributed air pollutant, is it sulfur dioxide? No, it is carbon monoxide. And what is the best biological indicator of air pollution? It is nothing but lichens. Okay, all right. Now see, all are indicators of air pollution except Soiling index. It is suspended particle count. Yes, SOT. McArdle's index is a measure of sweat rate. Okay, it is not an air pollution indicator. Okay, the amount which is recommended, like up to what can be tolerated, is 4.5 liters of sweat per 4 hours. This is also a PYQ. Okay, sweat rate 4.5 liters per 4 hours. Okay. All right. Now I said there's air quality index. So air quality index tells us what is the level of pollution. Okay. Now this has been given by whom? This has been given by Central Pollution Control Board. Okay. And this takes into consideration most important particulate matter 2.510, sulfur dioxide, nitrogen dioxide, carbon monoxide. Okay. Not carbon dioxide, carbon monoxide, hydrogen sulfide, and we also have to look into the air for ammonia and lead and polyaromatic hydrocarbons. Okay, so this is nothing but hydrocarbons. Now, what was the question? They asked about AQI levels. So just look over here. If the AQI, now you know at green color the traffic is moving, so good. Okay, 2 shades of green, dark and light green, good and satisfactory. AQI 0 to 50, 51 to 100. Up to 100 AQI is okay. Then 100 to 200 yellow, moderate category, and 201 to 300 guys, orangish kind of thing, that's poor. Okay? 2 shades of red, 301 to 400 very poor, and 401 to 500 is severe. Please remember there is no very severe category. Okay? No very severe category. That does not exist. A very severe category does not exist. So 401 to 500 is severe category. All right. What are the instruments used to measure air quality? Now we have different instruments to measure the air humidity, all right, velocity of air. So let us see them. So the first one over here is Carter thermometer. This is one of the most expected images. Okay, most expected. Now you can see how can you identify it with thin and narrow bulb, guys. Okay, you can identify it with a thin and narrow bulb. And you remember kata, kata means to bite. Okay, so a red colored dog has bit. That's how, this is red in color, that's how you can remember. A red color kata, bite kiya, okay? So a red colored dog has bit. So that is kata thermometer. What does this measure? This now measures low air velocity. Okay, it was also used to measure cooling power of air, but it does not provide very reliable estimates. So Carter thermometer readings as indicated of thermal comfort. Okay, so it was measuring what? Cooling power of air also, but does not provide very reliable estimates. So see, dry Carter reading more than 6, wet Carter reading should come out more than 20. Nowadays, the most important thing is it is used to measure low air velocity. Don't get confused with this instrument. What is this? Globe thermometer. This has what? This has a thick and wide bulb. Okay, thick and wide bulb. And what is this doing? This is used to measure nothing but corrected effective temperature. Okay, we call it as what? Corrected effective temperature, or it is also measuring what is known as radiant heat. Okay, so thin red color bulb, Kata, and thick wide bulb, almost blackish greenish shade, globe thermometer. What are the instruments that are used to measure air humidity, the moisture content? So there are different instruments. The name of them and images are important. Hygrometer hai, sling psychrometer. Okay. Then dry and wet bulb, hygrometer, and we also have what? Assmann psychrometer. All these are used to measure what? Air humidity. Okay? So look at this. This is a hygrometer. Can you see 0 to 100 markings? Hygrometer. Alright, this is very commonly used. This is a hygrometer. This one over here, you can get the image and what is does. So this is what? Sling psychrometer. Okay? What is this? Now don't say dry and wet bulb thermometer. No, this is dry. Because if you say thermometer, it is air temperature. This is dry and wet bulb hygrometer. And what is this one? This one over here is Assmann psychrometer. Okay? All right. Now there are some other pressures, other instruments. Anemometer. This is a Robinson anemometer. This was used to measure air velocity earlier. Now we are preferring Carter thermometer. All these are different types of barometers, guys. Aneroid and mercury barometers. They measure what is known as atmospheric pressure. Okay. Now, ventilation is a PYQ. Natural forms of ventilation are wind, perflation, aspiration, okay, diffusion, movement of air. But they ask you give some examples of mechanical ventilation. So just remember the names. This is actually a PYQ. They asked all are mechanical ventilation except. In the except, they had written what? Perflation, aspiration. Perflation, aspiration is natural. Mechanical ventilation are things like exhaust, plenum, balanced ventilation, and air conditioner. Balanced is a combination of exhaust and plenum through centrifugal fans and all of those things. See, all are following types of mechanical ventilation except. So I told you perflation and aspiration, guys. This is an example of natural ventilation. Okay? All right. Now let's quickly talk about waste disposal. Now when you talk about waste disposal, okay, so we are talking about waste disposal. I'll be summing up all the golden points for you. You know there's a solid waste and there's a liquid waste. So what is refuse? Refuse is solid waste. Okay. Now this solid waste is further divided into garbage, rubbish, and ash. Now, what is garbage? Garbage is the processed food waste from the kitchen. Processed food waste. See, actually refuse can arise from houses, domestic refuse, street refuse, industrial refuse. We are concerned with what? Domestic refuse. Okay, the one which is generated from our houses. So, garbage is processed food waste from kitchen. Okay, this is the processed food waste from kitchen. Rubbish is anything other like paper, wood, plastic, whatever. When you broom, whatever you can find, that is rubbish. Ash is the smoke. So now the more important question is, how is refuse disposed? So I've just put down the names for you: dumping, controlled tipping or sanitary landfill, incineration, compositing, manure pits, burial. So for each of this, I'll give you a golden point. Okay, so let's start with dumping. Dumping is what? Most unsatisfactory method. Okay, dumping is what? Most unsatisfactory method. It's not at all preferred, okay, because it's a site of nuisance. Second one, controlled tipping or sanitary landfill. Please remember, it's the most satisfactory method, or you could also say it's the best method for solid waste disposal. Okay, and this is achieved through 3 techniques, guys. TRA. What is this? This is trench method. Okay, ramp method, and one you have area method. Now the question always turns up from this trench method. Okay, so where do we do it? All right, there's a term modified sanitary landfills. You can just see compaction and covering are achieved once or twice a week. What is this compaction and covering? So I'll tell you. See, first I've told you there's a trench method. So first look at this image. This is a trench. Okay, so what do is we dig a trench. All right. So the question obviously will come is, what is the depth of the trench? So 2-meter deep trench is dug. This will require 1 acre of land per year, okay, to serve the needs of 10,000 population. This is a PYQ. So we have dig a trench, we have put all the solid waste inside, then we are going to cover and compact and cover it with this excavated earth. Where do you practice trench method? Wherever level ground is available. Okay, wherever level ground is available, like means a plain ground is available, we'll dig a trench. So I've just written over here, trench method chosen where level ground is available, 2 to 3 meter deep, wide constructed, refuse compacted and covered with earth. Inside this, the process of anaerobic digestion and aerobic oxidation takes place. Okay, so that is there. But important, they ask you, trench method is a method of solid waste disposal. It's one of the most satisfactory methods. So 1 acre of land per year is required for 10,000 population to construct trench 2 meter in deep. Ramp is suited for moderately sloping terrain where we don't have plain ground. And area method, wherever there are land depressions or disused quarries, we use area method. Okay, but the question will come, which is the most satisfactory method of solid waste disposal? Control tipping or sanitary landfill. In that, wherever there is level ground, we will go for a trench method. Next, incineration. Now, incineration method of choice to dispose of waste where land is not available. Okay, where we don't have a land to bury the refuse. But please remember, incineration is not preferred for solid waste disposal in India. Why? Because I'll tell you something. Whenever we are disposing of waste, okay, in the process of anaerobic digestion and aerobic oxidation, something important is produced, which is manure, which can be used in farming. So all the other techniques are generating manure. But if you burn all the waste, will you be able to generate manure? No. So that is why incineration is not preferred, because guys, manure is not generated. Okay, so incineration is only and only preferred in India for biomedical waste management. Okay, we never intend to burn solid waste, general solid waste, household waste, all that, because manure is not generated. So it's a loss. But yes, if land is not available, this is what we'll have to do. Fourth, compositing. I just want you to remember two mnemonic CBI. Okay, so compositing is integrated method of dispose of refuse also, and night soil also. So CBI, compositing. B stands for Bangalore method, I stands for indoor. Now Bangalore may you have AN, okay, so anaerobic hot fermentation, and indoor is based on aerobic method. Bangalore, BANG, so an is there, anaerobic hot fermentation, indoor is aerobic. Compositing is not preferred for municipalities with population over 1 lakh. But just remember, if you see the word compositing, Bangalore Indore method, it is for solid waste disposal. Manure pits are preferred for rural areas. Okay, this is a question which will come. For rural areas, how do we plan to dispose of the waste? By constructing manure pits. They are effective, simple and suitable in rural areas. Okay, so here all the garbage, cattle dung, everything is dumped into the manure pits and covered. So how many pits to have made on the backyard of the villages or of the houses in villages? You will see 2 pits are made. Refuse is converted into manure in 5 to 6 months time and returned to the field. So you got something useful out of it. You've gone picnic, you've gone camping. How are you going to dispose of the waste? By burial. This is also a PY. A trench, again 1.5 to 2 meter deep, will be excavated at the end of each day and the refuse will be put. For every 200 persons, trench of 1 meter in length is built, which will be filled in 1 week. Okay, so this is what are the questions which is turning up from solid waste disposal. Most unsatisfactory, dumping. Best method, sanitary landfill control filling. What do you control tipping? What do you prefer in that also? Trench method. Trench method may, how deep a trench is dug? 2 meter. How much land is required? 1 acre of land for a population of 10,000 per year. Okay. Then incineration, not preferred because manure will not be generated. Any other technique? Yes. The mnemonic is CBI, compositing, Bangalore and indoor. We have gone to rural areas. How should I dispose this? We are living in rural areas. So what is it? Manure pits. 2 pits are made. And we've gone camping, picnic, something, deep burial. Okay. Next is sewage. Now, sewage we all know is nothing but liquid waste with excreta. Okay, and what is the composition of sewage is a favorite question. So, composition of sewage, guys, please remember, is, it's one of the favorite questions. 99.9% of water plus 0.1% of solids. Okay. Alright, next important thing, okay, if somebody asks you what is liquid waste without excreta called as, what is liquid waste without excreta? So that is known as sludge, okay, but liquid waste with excreta, everybody, is sewage, and you need to know its composition also. Next important PYQ is, how do you express the strength of a sewage? Is it strong? Is it weak? So we calculate what is known as biological oxygen demand, BOD. More important than definition are the value. So let's just give it a read. BOD is the amount of oxygen which is observed by a sample of sewage during a specified period, mostly 5 days at a specified temperature of 20 degree for aerobic destruction or use of organic matter. Okay, but more important is, it's the most important test done on sewage, and for a normal strength sewage, BOD ranges between 100 to 300. But strong sewages, when BOD is more than 300 milligram per liter, weak sewages when it is less than 100 milligram per liter. So the normal strength of the sewage, okay, is lying between 100 to 300 milligram per liter. But if it is more than 300, strong sewage. If it is less than 100, weak sewage. Another way to estimate strength of sewage is chemical oxygen demand, where we are using potassium dichromate to measure the strength of sewage. Okay, but there's something also known as suspended solids. So normal strength of sewage, if the level of suspended solids in sewage is 100 to 500 milligram per liter. Okay, then like here it was 100 to 300. Okay, here it is 100 to 500. It's okay. But what is strong sewage if the level of suspended solids is more than 500? And what is weak sewage if the level of suspended solids is less than 100? Now, just like, so you know, the definition of sewage is a PYQ, strength of sewage, most important test done, BOD, and the level. That is also a PYQ. Okay, suspended solid level is also a PYQ. Then, of course, they're going to give you some key points I've put down. See, most important test done on sewage, BOD. Most practical method, however, is COD. Most efficient method to reduce organic matter is aerobic, and highly concentrated sewage we will use anaerobic. Okay? So most efficient method is aerobic, but if it's a very dirty sewage, highly concentrated, we'll go for an anaerobic process. Now, just like solid waste disposal, of course, we need to know how to dispose of sewage. Okay. So, wherever you have sewered areas where we have sewage treatment plants, you have to know these names, guys. There is a technique of primary treatment which involves screening, grit removal, plain sedimentations. The bigger particles are removed. Then in secondary treatment, we have two things: trickling filter and activated sludge process. Now remember, activated sludge process is achieved through something known as aeration tanks. This will be present as buzzword in your questions. And this is more preferred. Okay, activated sludge process, everybody, is more preferred because it occupies less space. Trickling filters occupies more space. So trickling filter as a method of secondary treatment of sewage is not preferred. All right, but activated sludge process is something which is preferred. And there are certain other methods also. You could be asked the names like sea outfall, river outfall, land treatment, sewage farming, oxidation, ponds and ditches. They rely on the natural process of photosynthesis. Okay, natural process of photosynthesis, guys, to purify sewage. Okay, to purify sewage. All right, natural process of photosynthesis. Okay, so you need to know the names of the method. Dekho, this is modern sewage treatment plant. So primary treatment through screening, grit chambers, primary sedimentation tanks. Secondary is through biological treatment, activated sludge or trickling filter. Here we are using activated sludge, which consists of aeration tank, and other methods I've already taught you. What is this? This is trickling filter. Now can you see how much of space it is occupying? Yes, it occupies very large space. Okay, it is a secondary method of sewage treatment. Secondary method of sewage treatment. But the important thing, guys, is it is not preferred. Okay, why? Because it occupies large space. So there's a layer of rocks and gravels over here. On top of this, a slime layer glows. Okay, biological layer glows, which treats the sewage further. But what do we prefer for modern sewage treatment? Activated sludge process. Okay, this is modern method. It is based on aeration tanks. So if you see the word aeration tanks, activated sludge process, it is for sewage treatment, secondary. All right, so that is important. So why is activated sludge process preferred over trickling filter? Because it is suited for large cities, because it does 1 acre of activated sludge plant does work of 10 acres of percolating filters. Activated sludge plant occupies less space and requires skilled operation. Trickling filter is only preferred for small town as it is cheaper to install. What? For larger cities and all, you prefer activated sludge. Okay, so if you see a diagram like this, the important thing is remember the word aeration tank with activated sludge process. What is this? This is oxidation pond, guys. Okay, this relies on the process of photosynthesis. See, they can ask you what are the methods of sewage disposal, so you need to remember this. All right, oxidation pond is used for smaller community. Bigger cities, activated sludge. Smaller towns, trickling filter, and for communities we can have oxidation pond. Okay, all right, so that is important point. Now what is this septic tank diagram is again important because this is for the household treatment of sewage. Okay, this is what household treatment of sewage. Now any community which does not have any access to sewage treatment plants, how will you treat the sewage? So household treatment is achieved through septic tank. Okay, now in this septic tank sewage enters. Now when we eat food, the food gets digested in our stomach. So inside the tank, all right, a question can come. What happens inside tank? Digestion. Okay, anaerobic digestion. Then the waste goes outside in the soil. So outside what happens? Aerobic oxidation. This is a PYQ. Okay, aerobic oxidation is happening outside. Inside digestion, outside oxidation. Okay, and always remember 500 gallons of sewage is admitted. 500 gallons of sewage can be admitted in these tanks. Okay, they can be admitted in the tank. All right, so that is important. What is happening inside and what is happening outside? It is household treatment of sewage. Content of the tank should be cleaned every 1 year by a process called as sludging. The sludge can be disposed of by trenching. Okay, sludge is this, the solid matter which is collected down. Scum is the greasy matter. So you need to clean this every at least 1 year. Okay, all right. Now, what is the main program for environmental sanitation? Only know this, Kayakalp. It is very, very important. This is for environmental sanitation. Okay, remember its diagram also, because environmental this thing. So there's an image of a tree. How the hospital hygiene and waste products are disposed, that is also contributing in this Kayakalp. Now look at the question. All are methods of sewage disposal except. So I told you Bangalore method, CBI is solid waste disposal. Otherwise, river outfall, land treatment, oxidation pond, all are sewage. What is the maximum permissible level of occupational exposure to ionizing radiation per year to the whole body? Okay, so 5 rads per year is allowed. Okay, that we'll see in radiation. Trickling filter is primary treatment or secondary treatment? Secondary treatment of sewage for smaller towns. Now, just a few questions on noise. What do come? So that was about sewage. Okay, so it's very important. We've revised water, air, and sewage. All these things that I'm showing you in rapid revision videos are PYQs also, guys. Okay, so daily exposure of up to 85 decibel is the limit people can tolerate without substantial damage to their hearing. Noise threshold for pain 140 decibel. Auditory fatigue occurs at 90 decibel. Rupture of tympanic membrane, exposure to noise above 160 decibel. Permanent deafness is repeated or continuous exposure to noise around 100 decibels. All right. All these are facts, but they are all PYQs which you must revise and go. Next, light came in a question this time only. So I'll just tell you about light. Okay. Suppose you want to study. There's no electricity. You light a candle. How will you remember? Okay. You light a candle. This is your study table. Okay. So you go and you are sitting over here. All right, and you light a candle like this. Okay. Now, this candle has some brightness, okay, or it has some power, or it has some intensity. So, power, brightness, or intensity of light source is measured in candela. Okay, so luminous intensity is power or brightness of a light source. Okay, if you see the word brightness of a light source, then also it is candela. Okay, brightness of a light source, candela. Then what happens? The light starts to flow like this. So what is this? Flow of light. And it looks like it is flowing through a lumen. So that is what flow of light? Luminous flux. Luminous flux is a measure of flow of light and the unit in which it is measured is lumen. So the light is flowing. Alright. So that is flow of light which looks like it's going through a lumen. Okay, so that is the unit in which it is measured. Then it falls on the surface and illuminates it. Okay, it falls on the surface and illuminates. Illuminates में amount of light reaching the surface, LUM की जगह it is LUX. So the unit is lux. Then there is some light emitted, re-emitted from the surface. So that is brightness. So brightness of the surface. Okay, if the word is used brightness with surface, that is Lambert. But if you use the word brightness of a light source, that is intensity, power, candela. Don't get confused. Many of you do get confused over here, okay? Brightness of a light source, if I say, is luminous intensity. But brightness or amount of light which is re-emitted by the surface, that is Lambert. Okay? So see the question, luminous flux. Flux is flow of light. Flow, it looks like, look over here, luminous flux, flow. Flow of light means it's going over here like through a lumen. So the answer is lumen. If I ask you brightness of a light source, it is candela. Okay? So just look at this diagram. You're lighting a candle, it gets lit, intensity, candela, brightness, starts flowing, flow, flux through a tube-like kind, lumen, falls on the surface, illuminates it, लम से लक्स हो गया, then light re-emitted from the surface, brightness, B से लैम्बर्ट. ठीक है? Okay. Now some last few points. Natural illumination, daylight illumination is measured by daylight factor. Please remember this is PYQ. Daylight factor in living room should be how much? 8%. Daylight factor in kitchen should be 10%. Okay. Daylight factor in living room is 8%. Daylight factor in kitchen should be 10%. Housing standards is important. So most important is setback. What is setback? Setback is the open space around the house. There's always a built up area and there's always an open area. So in what portion, how much I have made my house and how much open space is left around the house. Now in rural areas, we can still leave open space around our houses. From urban areas, we go to rural areas, to our villages to relax. Okay. So we can sit back and relax. Why? Because the open space left is a lot. So open space in rural area is 2/3. PYQ. Open space in urban area which you can leave 1/3, because in urban area already place we don't have any space. So how can you expect me to leave some space? Still open space in urban areas which is left around the houses 1/3. In rural areas, go sit back and relax. You have so much big farm or this thing farming is being done. So the open space left is 2/3. Just remember it that way. Floor area, one person requires 70 to 90 square feet. 2% requires 100 to 110 square feet. Very, very important. Okay, next. Roof, height of 10 feet. Okay. Wall, 9-inch brick wall plastered. Windows, living room provided with at least 2 windows with one opening directly to an open space. Windows to be placed, like if you look at the height of the window, if there's in your room, you just glance through it, it should be placed at a height of less than 3 feet. Windows should cover 1/5 of total floor area. Okay. And doors and windows should cover how much? More than 2/5 of total floor area. Please remember this. This is very, very important. All right, what about cubic airspace? So airspace of at least 500 cubic feet per capita is provided. Preferably can go up to 1000 also. Minimum number of living rooms should be 2 and at least 1 can be closed for security. Daylight factor more than 1%, not more than 5%, more than 1% over half of floor area. Ventilation, to ensure ventilation, please remember doors and windows should be diagonally opposite. Okay. But most important they ask over here is what is the setback? Roof का height कितना है? Doors and windows combined. Floor space कितना होना चाहिए? Cubic space, how much should it be? All that is there. All right. Overcrowding, always remember it is done by 3 criteria, which is number 1, person per room criteria, floor space per person criteria. ठीक है, And the third one is person per room criteria, floor space per person, and sex separation criteria. Okay, what is sex separation criteria? All right, so that is 2 individuals more than equal to 9 years of age. Okay, not husband and wife, are obliged to sleep in the same room. Okay, so 2 individuals more than equal to 9 years of age, not husband and wife, are obliged to sleep in the same room. Now, person may 1 room if it is more than 2 person, overcrowding. 2 rooms if it is more than 3 person, overcrowding. 3 rooms if it is more than 5 person, overcrowding. Floor space, 1 person, okay, should get 70 to 90. 2 person should get 100 to 110. Now, when you have to calculate overcrowding, okay, whether it's present or not, please remember a very important fact. Infants up to 1 year not counted, okay, but children 1 to 10 years, they are counted as how? They are counted as half. Okay, infants up to 1 year you will not count, but from 1 to 10 years they'll be counted as half. Okay, just have a look at this slide. Standards of ventilation, cubic space, fresh air supply of 300 cubic feet per hour. Air change actually आया हुआ है PYQ, so I have putting it. ठीक है, 2 to 3 changes per hour in living room, 4 to 6 changes per hour in workroom. Okay, that is standard of ventilation. All right. Now, if you talk about radiations, you know, man-made or natural and man-made. Man-made sources is important. Skin dose to patient from single X-ray film is 0.02 to 0.3 rad. Radioactive fallout is noted from all these things: iodine, cesium, strontium 90. Okay, some facts: skin dose of a patient from a single X-ray film varies from 0.02 to 3 rads. Maximum permissible dose, this is important, 5 rads per person per year. All right, thickness of lead apron, this is important. To prevent exposure, should be more than equal to 0.5 mm. Okay, these are some of the facts that could be asked from radiation also. So, hello dear students, welcome back to this rapid revision of screening, an important chapter, lots of definitions, images as well, and of course calculations. Okay, so first, what is the definition of screening? If you remember, it is the search for unrecognized disease or defect by means of rapidly applied tests, examinations, or other procedures where in apparently healthy individuals. So, the first question that turns up from screening is, are you applying a screening test on diseased individual, healthy, or apparently healthy? So, we are applying a screening test on apparently healthy. That means they appear to be healthy. They might be, some pathogenesis might have started in the body, but they are not yet presenting with signs and symptoms. So, the real question is that, where does the application of screening actually hold? That can we detect a disease, all right? Can we detect a disease before person goes on to develop signs and symptoms? Before person develops signs and symptoms, can we detect a disease before person develops signs and symptoms? A very basic questions in community medicine. So what is the answer to that? That yes, the disease can be developed before a person develops signs and symptoms. So that is yes. How? By screening test. All right. So where is this screening test applied? If you remember the concept of iceberg, what had we studied? That there is one tip and there is one hidden portion. Right? So what was this tip, guys? This tip was the cases which were diagnosed. All right. Tip is made of the diagnosed cases, those who are presenting with signs and symptoms. Right? Okay. They were presenting with signs and symptoms. But we are concerned about this hidden portion. Why? Because this is the population which is apparently healthy. Okay. Apparently healthy. That means they appear to be healthy. That means what? This apparently healthy portion, pathogenesis started Okay, pathogenesis has started, but no signs and symptoms yet. Okay, but no signs and symptoms yet. So we are trying to detect the disease before signs and symptoms develop. That is like a cancer. Before the person progresses to stage 3, stage 4, we're going to detect it early so that we can provide timely intervention and prolong the life of the person. And what is this? Water around the iceberg. So water around the iceberg, everybody, was the healthy population. Okay, so if you want to revise the detail of iceberg, you can refer to the chapter Concept of Health and Well-being. Okay, so this was the tip, this is the cases and the hidden portion. Now this hidden portion is contributing to the maximum prevalence of disease, and we have to apply a screening test to this hidden portion on apparently healthy population. Okay, so the first question that comes is, screening test is applied on healthy diseased apparently healthy population, so it's applied on apparently healthy. Second question, guys, go back to the levels of prevention. Screening test is an application, is an example of which level of prevention? Primordial, primary, secondary or tertiary. So screening test is applied to make an early diagnosis. Like cervical cancer, we do a visual inspection with acetic acid to make an early diagnosis, pap smear and early diagnosis, okay, before the person has actually gone to frank stages, when the pathogenesis starts. So another golden point you will remember over here is that screening test is an example of, okay, or screening is an example of which level of prevention? So it is an example of to make an early diagnosis and provide timely treatment, secondary level of prevention. That's a golden point. Okay? So screening test is applied on this hidden portion. What is the contemporary of it? Diagnostic test. Where do you apply a diagnostic test, guys? So the diagnostic test is applied here. All right, on the people who are presenting with signs and symptoms. If a person comes to me complaining of polyuria, polyphagia, polydipsia, I have to do a FBS. Okay, so that is where a diagnostic test is applied. So what's the difference between screening test and diagnostic test? This is a PYQ. Okay, we have just put down for you so that we can rapidly revise the difference between screening test and diagnostic test. So look at the first point. Screening test is done on apparently healthy. Okay, but diagnostic test is done on a person, on an individual who's actually going to present with signs and symptoms. So those people who are actually sick, okay, on them we'll do a diagnostic test, very easy. Now screening test is applied to apparently healthy. So we are applying screening test to groups of individuals. To a group, we go to a community, we screen all the elderlies for diabetes. So screening test is applied to groups, okay, because they are apparently healthy. So we can go screen an entire community of elderlies for diabetes or hypertension, whatever. But diagnostic test is applied to a single patient who's actually presenting with signs and symptoms to you in an OPD. Now, like I discussed in the main videos also, the test results of a screening test are arbitrary and final. Now, what is very important that when you see the word final, don't think here we are referring to a diagnostic test. No, it is saying that the test results, okay, are arbitrary and final. What does this mean? And also let's look at the second point also. It is based on one criterion or cutoff point, okay? But look at diagnostic test. The diagnosis is not final but modified in light of new evidence, diagnosis of some of all evidence, or it is based on evaluation of a number of symptom signs and lab findings. So point number 3 and 4, we are going to read it together. So if you see a question like test results are final, is it screening test or diagnostic? I've seen many of students marking it as diagnostic, thinking that the word final is there. No. Here what it means is that we have kept a cutoff. Okay, like suppose to diagnose hypertension, I've kept a cutoff of 140/90. So all the individuals who are coming more than 140/90 are screening test positive. And all the individuals who are going to come as less than 140/90 are screening test negative. So that 140/90 is the cutoff which is final, okay? But if we are applying a diagnostic test, even if the MRI says this is a disease or this is what the disease is, the clinician is still going to consider the signs and symptoms that the patient is presenting with, okay? Therefore, diagnosis is always modified in light of new evidence, and it is the sum of all evidence. Plus, screening test results are arbitrary and final, okay? Like you could take a cutoff 120/80, I can keep as 140/90, but whatever cutoff we take is going to remain throughout, okay? And when you talk about screening test, it's based on one cutoff criterion. The cutoff is final, all right? But diagnostic, again, test is always a clinician will consider signs and symptoms. So obviously, screening test is less accurate. It's just filtering out people who are likely to suffer from the disease. Remember one thing, screening test is simply filtering out people, okay? It's simply filtering out people who are likely to be suffering from disease, okay? So it's just filtering out people who are likely to be suffering from disease. Less accurate. But diagnostic test is more accurate, okay? It's confirming something, right? Plus, now screening test, should it be expensive? No, it's you're applying to a huge group. Can you apply a very expensive test to a whole group? Can you use MRI as a screening test? No, it will be very expensive. So screening test has to be less expensive and diagnostic test has to be more expensive, okay? Now, screening test, remember, is not a basis for treatment except for certain diseases like TB. Okay, sputum smear microscopy is both a screening and diagnostic test. For a large population, I can do a sputum smear, and based on the result, I can start treatment also. But generally, screening tests are not a basis for treatment. Diagnostic test is used as a basis for treatment. Now, who's going to request for a screening test? I think I am healthy. Will I go and ask somebody to test me? No. So the investigation request or the screening test initiative comes from the investigator providing care. That means government, non-government organizations. Okay. So they are from agencies that provide care. They are going to screen a population. But diagnostic test request is always from a patient because he's presenting with signs and symptoms. So when we develop signs and symptoms, we go to the doctor. Understood? The difference between screening and diagnostic test is absolutely necessary, okay? The most confusing point I've told you, if you see the test results are arbitrary and final, please don't mark it as diagnostic. If you see that they're based on one cutoff criterion, don't mark it as diagnostic. It's referring to screening test, okay? Done. Chalo. Next, now what is this diagram? A very, very important diagram over here. Okay. So here, this is the concept of lead time. All right. Now, application of screening test importance. Okay. You will come to know from this diagram. Importance of application of screening test. Okay. Why do you have to apply a screening test? When a screening test is applied, we can detect a disease early. Okay, before the person presents with signs and symptoms. So ultimately, what can you do? You can prolong the survival of the patient. In other terms, you can also cure the disease. So look at this point A. Okay, now point A is the disease onset. Okay, what is point A over here? You get the labeling also. Okay, disease onset. The agent is in my body. What is point B? What is point X? What is point Y? Y is the outcome. It's already written. Now, what is point B? Okay, so always remember B over here is the first possible point of detection. Okay, first possible point of detection. That is what is point B. What do I mean by first possible point? That the person does not have signs and symptoms right now. Okay, so no signs and symptoms present. Okay, no signs and symptoms present. The person does not present with any signs and symptoms. So that's the first possible point of diagnosis. What is point X, everybody? So point X is the critical point of diagnosis. Critical point of diagnosis means, or detection means, if I want to gain advantage, if I want to add some extra years of life to a person, I need to apply the test at point X. What is point Y, guys? Point Y is the, what is point Y? Okay, point Y is the usual time. All right, usual time of diagnosis. What do I mean by usual time? Usual time means that the person now presents with signs and symptoms. Okay, the person now presents with signs and symptoms. So he has gone to the doctor. All right, so that's the usual time. What is Z? So outcome. This Z is actually the outcome. Now, after diagnosis, only outcome can happen. Outcome can be in the form of recovery. It could also be in the form of the person who wants to develop some disability or death. Okay? So what is B, guys? The first possible point of diagnosis or detection where the person does not have signs and symptoms. X is critical point of detection and Y is the usual point of diagnosis. Now, what should I do? Instead of applying a test at point Y, when the person, generally, where would the test have been applied? When the person was presenting with signs and symptoms. So here he has signs and symptoms, okay? So instead of applying the test at point Y, when the person is actually presenting with signs and symptoms, I have gone and applied the test at point B, where the person does not have signs and symptoms. Okay, so I'm trying to detect the disease before signs and symptoms. Pathogenesis has started. So I am leading in the early detection of the disease by this B to Y. And this B to Y, everybody, is the lead time. Okay, I'm leading in the early detection of the disease by this interval, which is B to Y. So instead of applying the test at point Y, I have gone and applied the test at point B when the person does not have any signs and symptoms. So I'm leading in the early detection of the disease by this interval B to Y, which is lead time. What is screening time? Between B and X. Okay, X is the critical point. If you want to gain a substantial advantage of screening, you really want to prolong the survival, you really want to detect the disease in early stage, please go and apply a screening test at least till point X. So B to X is screening time. Got it? Very, very important. So time gained by early detection of a disease, everybody, is lead time. Direct MCQ. Time difference between the earliest possible point of diagnosis and critical point. So I'm asking earliest possible and critical point. X is the critical point. This is screening time. Don't be in a rush and mark it as lead time. No. The time difference between earliest possible point of diagnosis and usual time of diagnosis, everybody, that is lead time. This one is most expected. Okay. So when we apply a screening test, we detect a disease early, all right, and ultimately what happens because of this? We can prolong the survival of a patient. Okay? So that is very, very important. This image was very important. Now, a quick look at the different types of screening tests. So you have already studied in the main videos also. Mass screening matlab screening test is applied to everyone in the population. Okay, irrespective of what? Irrespective of high risk. Okay, so mass screening is everybody is being applied a screening test irrespective of high risk. This is the least efficient form of screening. Okay, least efficient form of screening. Why? Because imagine I go to a community and I screen everyone, all right? I screen everyone for diabetes. I screen everyone for diabetes. But now I go to a community, next community, this is say A and this is B. In this community, I screen only elderlies for diabetes. So which is better? Now obviously among diabetes, they are among elderlies, they are expected to have more diabetes. So here prevalence would be more, right, of diabetes, prevalence more. So I'll be able to filter out more people who are likely to develop from the disease. But here I'm screening everyone. So everyone will include anybody who's 20 or 30 also. They have less chance of having diabetes. But elderlies have more chance, so the prevalence is more. So this type of screening where I'm only screening elderlies for diabetics is what is it called? High risk screening. So the second one is high risk screening or selective screening. Please remember it's also called as selective screening. So we screen individuals at high risk. Okay, we screen individuals at high risk. Please remember this is the most efficient screening. Okay, this is the most efficient screening method. Why? Because we will be able to filter out more people with the disease. Filter out more people likely to be suffering from disease. Why? Because in such a situation, the prevalence rate is going to be more. Okay, so high risk screening is that. Example, instead of screening everyone, my priority is to screen all women with family history for breast cancer. So I have more chance of finding women who are going to develop breast cancer if I screen those who have a family history. Okay, so screen all women with family history of breast cancer. Similarly, screen elderlies for diabetes. All right, so that's high risk. What is the next one? Multi-phase screening. What is multi-phase? See, in phases, multi-phase. That means it is application of 2 or more screening tests in combination to a large number of people. First thing, multi-phase means 2 or more screening tests to a large number of people, but at one time, to detect a single disease. Okay, so defined as application of 2 or more screening tests in combination to a large number of people at one time than to carry out screening tests for single diseases, separate screening tests for single diseases. That means suppose I have a disease called as cervical cancer. Okay, now for cervical cancer, I've put a camp. In the camp, a camp will be attended by a large number of females, huge number of females. Now, I can also get a questionnaire filled from the women, okay, finding out about their risk factors. I can also do a VIA. I can also do a pap smear. So, in a camp, it justifies large number of people and it also justifies application of 2 or more than 2 screening tests to a large number of people to detect a single disease, which is cervical cancer. So, this is an example of what? Multi-phase screening. But what is multi-purpose? It should fulfill more than one purpose, which is purpose over here means I should be able to detect more than one disease. Multi-phase is for one disease, many tests applied at one time. Multi-purpose is I'm going to find out about more than one disease. So it is screening of a population by more than one test done simultaneously to detect more than one disease. Okay, like example, very, very important, we screen pregnant females. Okay, we can screen pregnant females at one time. If she has come to me, I can screen her for hemoglobin, Rh status, VDRL, syphilis, HIV, and also I can do HBsAg. So isn't it fulfilling more than one purpose? I'm detecting so many diseases, not just one disease. Understood? So multi-purpose means you have to screen a population by more than one test which are done simultaneously to detect more than one disease. Okay, so pay very good attention to the difference between multi-phase and multi-purpose. Multi-phase means it's only one disease with many tests. Okay, multi-purpose, we are going to apply many tests to detect many diseases. All right, so that is important. One more is case finding or opportunistic screening. So a person has presented to the hospital with the comorbidity. I, as a researcher or as a healthcare provider, I am taking that opportunity and screening him for other conditions, diabetes, hypertension. Okay, so that is case finding or opportunistic screening. All right, so that is again very important. Now look at this, types of screening tests. If we do random blood sugar for people residing in an urban slum, what is it? This is of course mass screening. You are screening everybody for diabetes. But if you screen CVD in elderlies only, what is this? High risk screening. Screen for TB in resettlement colonies. See, resettlement colony are like urban slums only. So when you screen them for TB in resettlement colonies, it is high risk. Why? Because TB is more likely to be present in lower socioeconomic classes. So screening for TB in resettlement colonies become high risk. Screening for cervical cancer in lower socioeconomic status, again high risk. Multiple sexual partners and also unhygienic conditions. Annual health checkups. Now, annual health checkups is an example of multi-phase screening. For one disease, okay, like for cardiovascular diseases, we can screen with a lot of tests. Okay, so that is annual health checkup. Health camps again is what? Multi-phase screening. Any of this can come. Pregnant woman, so we want to serve more than one purpose, that is detect more than one disease. So this is what? Multi-purpose screening. Okay. All right. There is one more type of screening which can come in your exams, prescriptive screening and prospective screening. Now, prescriptive screening is screening of people for their own benefit. Okay, screen for screen for own benefit. But what is prospect? For a better future, for a better prospect, okay? So this is screen individuals for others benefit, okay? Screen individuals for others benefit. Here prescriptive mein you have to screen individuals for own benefit, but in prospective you have to screen individuals for other benefit. So now own benefit means prescribe, like we prescribe drugs, like drugs are prescribed for our benefit. Similarly, screening is being done for your own benefit. So when you're screening for your own benefit, it becomes what? Secondary level of prevention, okay? Secondary level of prevention. But when we are screening for others' benefit, okay, it is primary level of prevention. All right, like you can screen the example, we can screen travelers or migrant population. Why were we screening the people who had a travel history for COVID at airports? Because they were a risk factors for the individuals of the country in which they had come. All right, so that becomes a primary level of prevention. But when we screen a neonate for neonatal hypothyroidism, it's for the neonate's own benefit. When we screen a woman for cervical cancer, it's for her own benefit, okay? So secondary level. So prescriptive screening is for, what is the purpose? If anybody asks you, it is case detection, okay? But prospective is for disease control. Okay, this is the difference between prescriptive and prospective. I'll give you a lot of examples. See, screen neonates for neonatal hypothyroidism, screening for deafness in children, blood sugar testing for diabetes mellitus, mammography for breast cancer, PAP for cervical visual acuity. These are all examples of prescriptive screening. Why? Because it is for the benefit of the person. All right, okay. But if you screen immigrants for infectious disease like TB, COVID, HIV screening for blood donation, okay? Now, if I go to donate blood, they screen my blood. It's not for my benefit. It's for the benefit of the others who's going to receive my blood. HIV screening in ANC mothers. How is it beneficial? How is it prospective? Because when you screen ANC mother for HIV, it is why? To prevent mother-to-child transmission of HIV. So this is what? For the baby's benefit, okay? This is for the baby's benefit. Health checkup for person working in food industry, okay? This is for your benefit. You are going and eating from the restaurants, okay? So these are all examples of prospective screening. This is a PYQ. You have to know prescriptive versus prospective screening. Now, this is just a chart where I've provided you some screening test, diagnostic test. You can go through that. Remember, for TB, guys, like I want to tell you that sputum can also be used as a screening test, okay? For TB, if you have to screen a large community for TB, you use sputum only. All right. HIV, ERS battery. What was ERS battery? You've done it. E was ELISA, okay? And R is rapid and S is simple, right? So 1 out of the 3 tests, 2 out of the 3 tests, and 3 out of the 3 tests. But Western blot is confirmatory. Malaria may, any case of fever, we can screen. All right, we prepare a peripheral blood smear, stain it with Jaswant Singh Bhattacharya stain, and also rapid diagnostic kits. Okay, so similarly, you can go through this table. Like breast cancer screening test is mammography. All right, but if we have young women, all right, in whom who are less than 40 years, okay, because of dense fibrous tissue, mammography cannot detect. So in that case, we recommend in India breast self-examination. Although in young women to detect breast cancer, we should do an MRI, but that cannot be used as a screening modality. It will be too expensive. Diagnostic test, FNAC biopsy. Similarly, VIA for cervical cancer is preferred at sub-center and PHC levels. At Pap smear is preferred at higher levels. Okay, all right. So this is just one of the things. Okay, coming to the next part, which was properties of a screening test. Now, what are the properties of a screening test? Like we have read in the main lectures also. Number 1, acceptability. Number 2, reliability. And number 3, validity. Now, what are these? Acceptability, because you're offering them to a large number of people who are apparently healthy, a test has to be acceptable. We cannot use any embarrassing test. Reliability, what are the other tests? What are the other names? The findings should be reliable, repeatable, replicable, reproducible in similar settings. Okay, so what are the other words? Repeatability, reproducibility. Okay, reliability, repeatability, reproducibility. All right, any of this can come in your exams. Consistency. All right, and what is one more word? Precision. Okay, in fact, these are all PYQs. And what is the other name for validity? It is accuracy. How valid is a screening test result? That means how close it is to a diagnostic test result. If the diagnostic test result is saying that I am diseased, did the screening test also say that? So how close a screening test value is to the gold standard value? So you need to know these different names. Now I'll just ask you some few definitions before we go to the formula. See, ability of a screening test to differentiate diseased from non-diseased. Okay, that means all the true positives from all the true negatives. Nearness to the true, actual or gold standard value. What is the measure of that? Nothing but validity. Okay, validity or accuracy. Validity or accuracy of a screening test tells us how close we are to the gold standard value. Okay, ability of a screening test to identify all those who have the disease, or probability of having a test positive out of the total disease. If 100 are diseased, then what are the chances of having the test positive? Okay, so what is this? All those who have the disease, sensitivity. Ability of a screening test to identify all those who do not have the disease, or probability of having the test negative out of total healthy. If 100 are healthy, then in how many people screening test came as negative? So that is what is specificity. We'll be doing this with formulas also. So sensitivity is detecting all those who have the disease, specificity all those who do not have the disease. Now, if I've come screening test positive, do I actually have the disease? So probability of having disease out of those tested positive, not out of those diseased. Okay, if we have been tested positive, do I actually have the disease is PPV. What was PPV, guys? Positive predictive value, right? And probability of not having the disease out of those tested negative. So if I have been tested negative, do I actually not have the disease? Okay, negative predictive value. PPV tells us, is the disease actually present? Okay, is the disease actually present? NPV tells us, is the disease actually not present? Okay, so we're going to look at this with the help of 2x2 table as well as formula. So always remember, like I've taught you, disease has to be on the column side. Yes, no. And screening test result, okay, ST result has to be on the row side. So positive, negative. And what do we do? A, B, C, D. Never A, B, C, D, right? So this is A, B, C, D. Now what is A, guys? If you remember, disease is present and screening test also positive. So what was A? True positive. Disease is also there and screening test is also saying you have the disease. What was B? Disease is not present but screening test says you have the disease. So false positive. In the first row, all positives. Okay. What is C? Disease is present but screening test has come out negative. So this is false negative. Disease is not present and screening test also says not present, true negative. So in the second row, guys, we have all the negatives. Okay. So the first formula that is there is sensitivity. What is the formula? I've just told you, ability of a screening test to identify correctly all those who have the disease. So over here, the gold standard would tell me that the disease is present in A plus C or in TP plus FN, and screening test has identified it in TP. Okay, what is specificity, everybody? What is specificity? So ability of a screening test to identify all those who do not have the disease. Okay, just listen to the definition and write the formula. Don't memorize. Those who do not have the disease. So how many do not have the disease, guys? Disease not present in B plus D, or you will say TN plus FP. Out of this, screening test has identified it in TN. ठीक है. Next, PPV. So what is positive predictive value? It is out of all those who've been tested positive by a screening test, how many actually have the disease? So how many have been tested positive? A plus B have been tested positive. Okay, so TP plus FP. How many actually have the disease? TP. And what is the last one? NPV. It is out of all those tested negative by a screening test. So how many have been tested negative? TN plus FN. How many actually do not have the disease? TN. You have come screening test positive. Do you really have the disease? That is PPV. You have come screening test negative. Do you really not have the disease? That is NPV. And everywhere, of course, we will be multiplying with 100 because it's always given in percentages. Okay? So just think, out of all this, which is the most important property of a screening test? Obviously, sensitivity. I'm applying it on apparently healthy. I need to filter out more and more people who are likely to be suffering from the disease. Okay? Also, one more thing, guys, PPV, you can remember all positives, NPV, you can remember all negatives. Okay? So, look at this thing which I wanted to tell you. Next thing, most useful property of a screening test, everyone, is always remember sensitivity. Okay? Diagnostic power of a screening test is given by what? Positive predictive value. But diagnostic power of a screening test to correctly exclude the disease is NPV. You have come out screening test negative. Do you actually not have the disease? Is NPV. Reproducibility, repeatability, reliability, consistency, getting same results. What is this? Precision. Okay. And validity or accuracy is how close we are to the gold standard value. Ability to differentiate true positives from true negatives. So formula, interpretation, some important questions, the definitions are very, very important for this topic. Okay. Next, now look at this relationship of predictive value with prevalence of a disease. This is very important PYQ. So suppose if the prevalence of a disease increases, okay, and a graph is plotted like this. All right. So what is this? Okay, and there could be another situation where the prevalence is increasing, but the graph is plotted like this. So here you will have PPV, here you will have NPV. Just remember one thing, positive predictive value is directly proportional to prevalence. Application based question here, negative predictive value is indirectly proportional to prevalence. If prevalence is increasing, negative predictive value is decreasing. But if prevalence is increasing, positive predictive value is increasing. So if you ever get a question with prevalence, it will first affect these predictive values. Okay. Then another thing, test in series, which is known as sequential testing or two-stage testing. And you also have what is known as test in parallel or simultaneous testing. So what is test in series, guys? That the second test is applied only on those who come positive on the first test. Okay, when we applied first test, all those who were positive, in them only we are going to apply second test. That is why it's in a sequence, two-stage. Okay, any of this name can come. Parallel testing means simultaneously. Both tests are applied together. Okay, so suppose this is a community, I'm applying a screening test which has a sensitivity of 90%. So if there are 100 diseased, okay, it will detect 90 as true positives. So now the second test, okay, second test will be applied on only these 90 people. If that also has a sensitivity of 90%, 90% of 90. So here what happens in series? Sensitivity decreases. But what is tests in parallel or combination? Both screening test 1 and screening test 2 is applied on the same population simultaneously. So in this case, always the sensitivity increases. Please remember, For a person to be called as positive when the tests are applied in screening test in series, both tests have to come as positive. Both tests have to come out as positive. Okay, both tests have to come out as positive. In simultaneous testing, the person is positive even if one test is positive. Okay, even if one test is positive, I mean suffering from the disease. Here, for the person to be suffering from the disease, both tests have to come out as positive. All right, so in series and parallel, what happens to sensitivity? It decreases, so specificity automatically increases. In parallel, sensitivity decreases, increases, specificity decreases. Okay, please remember, for a good screening test, okay, for a good screening test, always pay attention to the sensitivity. Okay, sensitivity should be high, but that doesn't mean specificity should be zero. A fair specificity also. All right, most useful property of a screening test is sensitivity. And series matlab we are applying both the tests, not together, but first test, all those who are positive, on them only we are going to apply the second test, and a person is diseased only if both the tests are positive. Parallel mein all the tests are applied simultaneously. Now what is this diagram? Maybe it can turn out, this is ROC curve. Yes, this is a receiver operator curve. All right, and what is this curve doing, guys? This curve is helping us decide the cutoffs. Okay, it helps us decide the cutoff. What cutoff should be selected? Or it helps us if there are two screening tests for a disease, which one should you select? So most important thing is they give you the markings on the X and Y axis. On the Y axis, you plot true positive. So true positive means we are plotting what? Sensitivity. On the y-axis, we plot false positive, which is what? 1 minus specificity. So now we see that there are different lines, a blue color, red color, and a white. Here it is absolutely, this is just for reference. Okay, so which test is better, the blue colored line or the red colored line? Obviously the blue colored line, because if you drop a perpendicular, look at the sensitivity that it's achieving 0.8. Okay, and the red would achieve somewhere around 0.5. Okay, plus area under the curve blue is much more than area under the curve red. Okay, so blue is better. All right, whichever has a high sensitivity. Okay, more area under the curve, better it is. More area under curve, it is better. All right, this is just the values that you can see. Up to 0.6, it is satisfactory, but if it is below that, it is unsatisfactory. Just the name of this, what is this? This is Kaplan-Meier survival curve. Okay, Kaplan-Meier curve. Kaplan-Meier curve is plotted for survival analysis. Okay, so we do what? Survival analysis from this. Okay, Kaplan-Meier curve. Now over here, look at this. Green color is without treatment and blue color is with treatment. Okay, so this is just telling that with treatment, that survival increases. Without treatment, it does not increase. Okay, so these are two image-based questions that can come. So this was about screening. Let's have a look at some MCQs quickly. Lead time refers to the time between first possible point of detection and usual time. First possible means no signs and symptoms. Usual time means signs and symptoms are present. Ability of a screening test to identify correctly all those who have the disease. Sensitivity. Those who do not have the disease. Specificity. If you've been tested positive, okay, if you've come screening test positive, what are the chances of you actually having the disease? Okay, screening test positive. Question is, what are chances of you actually having disease? Okay, actually having disease. So that is what is PPV. You have come screening test negative. Okay, what are chances? What are chances of you actually not having disease? So that is what is NPV. Okay? Probability that a person out of those tested positive on a screening test has in fact the disease. You have been tested positive. Do you actually have the disease? PPV. Sensitivity formula, ability to identify all those who have the disease. So disease, yes, no, A plus C was it? Okay, TP plus FN, and out of that, TP. Everywhere where it's positive, PPV. Where it's negative, NPV. And this one right over here is specificity. Okay, for calculation of negative predictive value of screening test, what is denominator? All negative. So look for a place where there is everything negative. This one. If a test is 90% specific, then what does it mean? See, 90% specific means that if I apply, it is the ability to identify all those who do not have the disease. So if test is applied on, please remember this is important, applied on 100 non-diseased people, okay, 100 non-diseased people, then it is going to give me, here it is 90%, so 90 as true negatives and remaining 10 as false positive. So 90% of non-diseased will be true negative. But if suppose the test was 90% sensitive, that means if the test is applied on 100 diseased people, okay, sensitive means if gold standard is applied on 100 diseased people, it will identify all the 100. So over here, if the test is applied on 100 diseased people, it will give me 90 as true positives and remaining 10 as false positive. So 90% of diseased people will be true positive is the sensitivity. Specificity means I am applying on 100 non-diseased. Out of that, 90 are coming as true negatives. Okay? So that's it for the rapid revision of screening. I hope it helps you. Thank you so much.